So much for coming. How are you all doing tonight?
Really grateful everybody could make it tonight. There was a lot of interest, and so you all are really special to us.
Yeah, we'll say a bunch of context-setting things about the event in the next couple of slides, but yeah, there was an overwhelming amount of interest, and we decided to keep this really small and intimate. So just to say, like, everyone is here is because we wanted you here and we're excited about it. So as much as anything that we will communicate, like gathering a quality group of human beings together who care about things that matter is part of the intention here. So yeah, we're honored and super thankful for you all to be here. And enormous shout out to Jessie Kate. Jessie Kate, are you here? Yeah. Thank you so much. Round for Jessie Kate in the fold. Huge love to Jessie Kate. Thank you for your support in making this happen. Yeah, hopefully we can like explore the potential and activate what's possible here at this space, which is called The Fold. And if you're interested in learning more about it, please talk to Jessie Kate or some of the folks upstairs. We'll try to fold it into some of the later part of the discussion, but yeah, like puns everywhere. Cool, so yeah, tonight is a salon with River Computer, prototyping eco-technical systems. I'm Austin.
And I'm Will.
So we'll just give a little bit of like context setting for what we're going to do here and about what we're not going to do here, so you all have some feelings for that, and then we'll set some sort of like intentions and things. So we'll do this evening in 3 parts.
Yeah, so we're going to kick off with an introduction and talk a little bit about the origins of River Computer, give you a little bit of context and about our intentions for the night, and share a little bit of the lore and the mythology behind River Computer.
In the second part, we're going to play with some sort of like diagrams or some devices, some ways of thinking about rivers in computing and living systems as computing systems. And we're tentatively calling that section Computational Diversity on a Dying Planet. And we'll kind of explore 2 tensions that are really important in our work and probably really relevant to a lot of you all's work on the notion of polyculture versus monoculture, and ideas of like interaction over or substitution.
Yeah, and then so we really want to land this work in some of our practical applications that we've been exploring, so it's not just in the theory realm. So we have one project that we've built called the Wind Trust that we'll be presenting, and then another project which is Living Covenants in Ingapui. And then we'll finish it all up with a Q&A at the end.
Mm-hmm. Yeah, so there's at any time, this like presentation should go for about like 40 minutes to a little shy of an hour. If at any time you get tired of us talking before the Q&A, you can go hang out upstairs or help yourself to a drink and like drop in and out as it feels appropriate for you all. So let's get started. This is an utterly crushed image. We did that on purpose.
Wasn't an accident.
Yeah. So a little bit of an introduction of this project and like what this is.
Yeah, so I'm Will, and I have a background building technical systems for agricultural projects and ecological projects. I've worked a lot on soil health initiatives and understanding food systems and some different biodiversity projects. And right now I'm building a geospatial computation startup and platform. And we've worked together over the years on various things together.
Mm-hmm. Yeah, and I'm Austin. I also go by AWS. My pronouns are they, them. River Computer is like a passion project for us right now, and maybe through more things like this, it will form and grow into its own thing, potentially with you all included. When I'm not doing River Computer, I'm the executive director of a nonprofit called Regen Foundation, which works in the space of like rights of nature and regenerative economics, entailing the blockchain. Yeah, I come from like a design and ecology background with a technical bent, and I guess I would just introduce this by saying that both of us are very like oriented towards like making things and prototyping and developing things. So we're not going to try to like sit here and hit you over the head with some kind of theory or pontificate it. We're like trying to get to the point where we can talk about some applications, and I think that's what's really animating our interest. So for me, I mean, I think it's all interesting, but I think the night will kind of go like that. So hopefully that will like match the sort of the boredom that comes when you just sit and hear people talk for a bit.
Yeah, so a little bit of context about how we formed. We went for a hike, and we want to invite you to go on a hike with us tonight and sort of meander through these ideas that we've been exploring together. And we want you to think of River Computer more as a provocation than as a statement. So we brought you all here tonight to explore these concepts with us and give feedback and really start a dialogue. And we also invite you all to sort of relax your conception of what you think of when we say computation and maybe broaden it a little bit and see what comes through this exploration.
Yeah, so some intentions that we have for this space is to get people to enroll in a hiking club / group chat / like hacker meetup that we can tentatively call River Computer. Our other intention was to gather like a really high quality assemblage of people together so that connections and like lateral relationships can just utterly grow on their own. I think that we're trying to find a space to rediscover what the notion of computation is from first principles and think of it as a kind of antidote for the way we might frame like the current crisis or crises that we're looking at right now. And ultimately to stoke curiosity around brainstorming applications and potential relevance for you all in this line of thinking and building, so that could be something we could do together over time, no obligation. So maybe one way of just like coming right out and talking about, can you all see the screen okay with us? Okay, well, I'm gonna cower a little bit. Is like, we've been working through and making this presentation, trying to come up with a way of describing what are the sort of assumptions that we realized were unexpressed when we were making and developing this project, but we realized had to be foregrounded right up front because maybe not everyone agrees with this. And maybe it starts with something that's like fairly straightforward, but then walks into a territory that's a bit more esoteric, perhaps. So we're utterly under the opinion that there's like a meta crisis that includes a climate crisis and a crisis in many different forms. And one of them is a kind of like biodiversity crisis. And I'm going to say that the biodiversity crisis is a cognitive diversity crisis, because in understanding how beings and organisms relate to their environment is a kind of thought, a kind of intelligence. So the more that we collapse and erase different diversity of environments, the more we're erasing the forms of intelligence that are native to them. And maybe one step further from that to say there's some connection perhaps between computation and cognition, that we're in a kind of computational diversity crisis. We're like funneling ourselves into a position of monoculture, and the container that we're having this conversation in isn't neutral. These things are veering towards like a lack of polyculture and a lack of pluralism. So we're just gonna like wear that on our sleeve and be like, if you're with us, then great. If not, then we can have a meaningful discussion about why we make those assumptions. I'm just gonna do this one too. Yeah. So maybe like computation is a fraught word, and we're probably gonna walk it to the point where it breaks, and we're into that because it will probably no longer be helpful. And that's kind of part of the point. A lot of people have strong opinions about this, and so by making something called River Computer, we're kind of nerd sniping the scene to be like, oh, I have an opinion about that. So maybe we'll get our working idea about what computation looks like out of the way now. And so inevitably, computation probably relies on some level of input that's through some processing of difference within that input turned into an output according to certain rules. We'll say that computation is the reliable transformation of inputs into pattern outputs by processing those differences through a rule-governed dynamic of a system. And in that way, those differences occur at its boundary through signals, gradients, perturbations, and data, and they're taken up and transformed and resolved into new differences according to the system's intrinsic structures. There's a kind of material substrate bend to the way we're describing this. Okay, so a bunch of stuff out of the way, like that's on our sleeve. We're just now getting going.
We've set context.
Yeah.
Okay, so now for a little bit of the lore and the mythology behind River Computer. So just to ground this is a river. We are talking about rivers.
This is what they look like.
Yeah, in case you didn't know.
Yep.
And we love rivers, and sometimes we walk around rivers and sort of pontificate and think about them. And we think about their behavior and how there's some complex dynamics in them, right? A river isn't just static. Sometimes it's on and sometimes it's off. And what's going on there? Isn't that interesting?
I should say this river isn't the one that we particularly started talking about River Computer around, but it's a kind of good emblematic one. Something that's interesting about this river is that it's intermittent, it's periodic, so it kind of turns on and off. It has two different states that oscillate. And so there's a question initially about like, how does this happen? How does what seems like a continuous analog fluid system begin to have sort of discrete states that turn on and off? And this is called an intermittent spring or a periodic river. And the reason that it turns on and off is because there's, in the geomorphology behind the river, there's a reservoir of water that's controlled and sort of gated by a siphon, is what it's called, which is essentially like a conduit that says only once a certain threshold is met within the reservoir that's upstream of the river does the entire reservoir drain through a kind of capillary action. So the river turns on and off and has two different modes because there's a kind of logic or threshold condition that is upstream of it that's determining whether or not it should turn on and off.
And here we're showing this deer scare mechanism, which is
called a shishiodoshi.
Wherein you have a bamboo tube that a trickle of water flows into, and you end up with a behavior that's similar to this periodic spring, where once the tube fills with water, it tips over, it triggers a bell that scares the deer away. Now, another analogy for this is an RC circuit that has this oscillator behavior that you can see over on the right. So this is sort of demonstrating a way in which, you know, these water systems can be metaphors or modeled with electrical systems. And if we wanted to, we could model other systems as well.
Right, so we can describe the behavior of the shishiodoshi or the periodic spring according to, like, we could map it onto an existing set of like representational schemes that we know about, like capacitors and oscillators and things like that. And people are really good at doing this. One of the sort of underlying interests in this project is that people use water as an analog for many other kinds of complex systems. And we're not actually going to talk about just like literal hydraulic computers. We're actually going to kind of tear this apart, but we're going to set it up first before we do it. So like this is a pretty common way of mapping voltage and current and resistance. I'll let you do these.
Sure, yeah. So if you wanted to, you know, it's a common explanation when you're studying electronics. Oh, electrons flow like water, like molecules of water. So if we wanted to model or think about the behavior of a resistor, oh, that's a kink or a shrinkage in the width of the tube. And a voltage drop is a pressure drop. And the current is, well, the current, right? And you can model series configurations and you can model parallel configurations. And here's the shishiodoshi where you can model these oscillators. And you can even design more complex systems where you model logic gates. And here on the right, we have this logical AND operation and exclusive OR operation. So if you wanted to, you could use water as a metaphor or actually an implementation of these sophisticated systems.
So that's kind of what got us first going, is like being on a retreat that actually a couple of people in the audience were also on, and going for a hike next to a river and thinking through like, well, what kind of like latent logic is already embedded into the system that we're looking at? Wouldn't it be interesting if we could understand that there's a kind of like logic gate that's embedded into the hydraulic logic here? And we're not calling this river logic, we're actually going to call this hydraulic logic, because we're just sort of extracting the mechanics of water and then using it to represent different kinds of electrical systems. So maybe, okay, this is interesting. The river is expressing some kind of like logic system, and you could compound those together to make a transistor, and then compound those together or cascade them together to make a semiconductor, or who knows. So from these like rudimentary examples, you can go further with it, and people obviously do this where they make like algorithms that are cascades. This is an adder that uses a system of logic gates, and here's a siphon system that's essentially doing binary math using the same logic. And it's not like that far of an extension to say we could use these kinds of, the logic of an intermittent spring or a siphon system to be an understanding like, yeah, maybe there's some rudimentary form of like binary logic, binary arithmetic happening in here for those who look closely enough or for those who care to see that. And this model, it goes further. The hydrologic is just like goes wild. If you all have ever heard of the Phillips machine from the London School of Economics, where they used hydrologic to model the London economy or the British economy in the 20th century. And with corresponding valves and basins and some level of siphon action and wicking, they were able to like basically describe a complex economic system. So we inherit this model where we understand like voltage to be slope and current to be the actual current of water, and we think about like liquidity and economies and things like that, and all of them draw from this sort of water metaphor. But that's not really what we want to talk about tonight, because that's sort of like a very kind of easy way, in a way, to mine the mechanics of hydrological systems to fit into the existing models that we have made of the world. And what we're interested in talking about is what existing kind of computation is latent within living systems like rivers in the first place. All of these, interestingly, have like containers in them. They have to like be filled and refilled. The intern's got to go out and like take the bottom reservoir and put it back up to run the experiment again. But they're not out in the wild. They're not like in the wild world. So we're not interested in trying to present like hydrological computers are this interesting thing and here's our demo. We understand it was totally ambiguous what we might talk about tonight. And some of you might have assumed that we were going to give you like here's our cool siphon computer look, and like it does binary math. But recreating a kind of computer out of a hydraulic system is in some way missing the point. I think it's kind of confusing the priors. And a lot of people really love Buckminster Fuller. I'm like, yeah, he's pretty good. But one of his famous things is like spaceship Earth. Like we have to treat Earth like a spaceship. It's like Earth is not a spaceship. A spaceship is a crude approximation of the life support system that Earth is. Earth came first, and we build these systems that might try to model or recreate the dynamics that we already see within living systems. But if it fits, like the Earth isn't a spaceship is trying to approximate a kind of Earth. And in a lot of the sort of hydrological projects, we see this process where people are sort of extracting the mechanics of hydrology in order to describe computational systems they're already familiar with. They're going to model how the economy already works. We're going to model a neoliberal model with hydraulics, or a feedback system with water. Okay, so yeah, we like to go outside. We really like technology too. You know, if you're into that, let's talk. That's kind of maybe why a lot of you all are here. I was backpacking in the Pacific Northwest a couple of years ago, and I really became enamored with this phenomenon that happens in the Strait of Juan de Fuca between the Olympic Peninsula and Vancouver Island. And this is called a siren buoy. So the first thing I'm going to draw the attention to you all about this is that it's not in a container. There's no intern that's refilling the system to run. The buoy's just out there in the world. And what the siren buoy does is that it has a system below water which is filling and discharging according to the intensity of the swell that's coming into the strait. And if the swell is sufficiently pressurized, if the swell is sufficiently intense, it will pressurize an air chamber that will discharge out of a whistle. And so you can hear the swell through its duration and its intensity of what's happening within the water system. And I was like, this thing is the coolest thing I've ever thought of. Oh my God, having this like intimate relationship with siren buoys. And maybe by the end of this talk, you all will too.
Yeah, so we wanted to think through what would it mean to, instead of adopting the logic of the hydraulic logic that we've been seeing, where you're taking the mechanism out of the medium, what would it mean to embed the mechanism in the medium, and how would we give voice to mediums and really experiment with different forms of computing and legibility for different natural systems?
Right, so rather than using the system to make a contrived model of what we already know, how can we use these dynamics to make legible the kind of patterns of information processing or quote computation that are already latent? And it's a kind of system of expression. It's a sort of pattern of sort of like legibility rather than using this as a medium or a replacement. We're not exactly sure how to describe this, but this one's out in the world. It's right. It's the Wild West out there, and it's living its life, and you might encounter it when you're backpacking nearby, whereas this is defined by being in containers. And people have created the containers and put it in, and they'll push it around. Right. And so part of the project of River Computer is to explore what are ways that our digital computing systems, the conventions of computing as we know it, that they can, rather than quarantine and like siphon the world into contrived models, how can we create better interfaces where different forms of computation are touching and interacting with each other? And the siphon buoy is maybe a good starting point.
Yeah, really, like, how can we let the swell sing, right?
So maybe one position, and we're going to kind of round out the first part of the presentation to say, like, primitives of, quote, logic are expressed across living and inorganic systems in all these different forms. And they form these complex relationships which cascade into dynamic action and state. And so it's not surprising that we're picking perhaps the metaphor of rivers is because the sort of cascading chain or the set of relationships that unfold is very common when we see like computational systems. So another way of framing that is to say, how can we interact with the conditional logic already latent in rivers rather than just trying to pump it into different siphon systems and create contrived models? This is a pretty famous USGS image of the Mississippi. She is wild, she is ancient, she cannot be contained. And they were mapping all the different behavior of what they called the river meander. This is Harold Fiske did this in the 20th century. So this is a meandering river. Consider this project and this discussion a continuation of this river's meandering, where we're trying to find a space where like projects and like curiosity can grow, rather than just trying to recreate contrived models using mediums that we bend to our will. So maybe at this point, computation might be kind of a misnomer. I mean, that's fine, but what would be an alternative? We're not really sure, and that's part of the invitation for this evening. It's like, what's the word that fits? And I think there's a lot of different words that might fit, or phrases that might fit. Maybe it's like codes of legibility. Maybe it's contracts, which is kind of a foreshadowing for what we're really going to talk about. So, begin part 2.
Right, so we want to call you back to our original slide and maybe look at it a different way. How can these living systems be expressed as computational diversity?
Right, so in the spirit of trying to create the same idea and approach it from another direction, we'll say, well, what is the possibility of a notion of like computational diversity? Is that a relevant question to be asking? And maybe harmony is a loaded word, but it's like, how can we find harmony in different kinds of computational ensembles so that we're not like inadvertently collapsing the world into a particular monoculture without realizing it?
Right. So we designed this quadrant system as a way of framing forms of computation. So you can see on the vertical axis, we've got fast computing versus slow computing. And then on the horizontal, we've got dry computing versus wet computing. And you can see computers, or what we typically think of as computing, occupying this dry, fast quadrant.
Yeah, and any kind of computer any kind of system that interacts with your dry, fast quadrant, like your computer's probably not going to like very much. I spilled water on my previous laptop and spent half my time in San Francisco trying to fix it. Computers don't like wet stuff. This is the dominant form, but by creating a space, we create the opportunity to maybe describe some other flavors of it. So what if we populated this sort of computational diversity space with a handful of other ways of thinking about computation? And in the fast-wet category, we might have like microbiology, the sort of transcription of DNA and things like that. Versus in the slow-wet, we might have the like freezing, arduous process of glaciation and the carving out of systems according to the tectonic forces and the hydrological forces of frozen ice. Or maybe down in the dry slow, we have a kind of domain of like mechanical or administrative computing.
So we could populate this graph and think about all the different forms of computing. And we'd place river computing in the wet and the slow that maybe we're blocking, and maybe adjacent to glacial computing. We could also think about like DNA transcription or microbial computing as in the wet and fast. And we could continue exploring different forms of computing.
So maybe there's a kind of mechanical system of dry and slow that doesn't move nearly at the speed of what we would think like a CPU doing, and that could be like a domino system that's purely like mechanical, or sort of like billiard balls, the models of the universe of things clacking together. And nicely within human and mechanical systems together, you might get something like semaphore, where you have human beings, like bodies of water themselves controlling different mechanisms. And maybe even slower, we have like bureaucracy, subway systems, administrative systems, organizational kinds of computing, the kind of algorithms you see people doing in larger sort of like protocols together.
But in the current moment, I think we see a hollowing out of these other forms of computing, a lack of diversity in computational style, where the dry and the fast take over the rest.
Right, and so maybe another way of looking at this slide is to say we've converged so squarely on what a certain kind of logic of computation or legibility, or what we'll get into talking about contracts is. We've converged so squarely into that these spaces are the reflex of that is that these spaces are like drying up and malnourished. So a sort of coding of this slide is basically a way of saying ecocide, that like the rivers and the glaciers are disappearing fundamentally. Biodiversity and cellular life is disappearing fundamentally. We're creating voids, literal death and erasure by conscientious and accidental means in all these other spaces of the sort of computational spectrum. And there's this collapse in the diversity of substrates in which we might call computation, and that's a kind of monoculture. And this feels really alarming to me, to us, in a way, because we are inadvertently filling the voids created through the erasure of all the other kinds of living systems on our planet with a kind of copy and paste of what we think computation looks like from only one part of the quadrant. So what we understand living systems to be increasingly becomes a way that we can create computational systems that model and reflect them, but they're not the same thing. So maybe you all are surrounded by this to a greater or lesser extent. There's a lot of like AI agents that claim to speak of mycelial consciousness or to speak on behalf of trees or bioregions. And I think like it's like a really, really risky thing to do to like fill the void created through our own like patterns of erasure with a kind of carbon copy of ourselves. We're like copy pasting web document simulators to pretend that they're forests or something like that. And what we get out the other side is like, I'm mycelial consciousness slop. And like part of the effort here is to sort of upgrade our potential in having this dialogue. And it's not to say like the different forms of agents, advocates, representations, digital twins and things like that don't have a place. But I think we have to be really, really careful about the ethics around how we're not subsuming one system by another that's the dominant, but actually trying to explore spaces of interaction.
So there's this collapse in the substrate of these different forms of computing, and this is a crisis, and it's a call to action, and it's terrible. And we see this framework we're exploring as an opportunity to be expansive and be excited about the future and all the ways in which we can give voice to other computing systems.
Right, so amongst the kind of call to a crisis around filling the voids of erasure with a monocultural model of computation, there's an upshot that we can rediscover a pluralism or a polyculture of what computation looks like, and then like potentially explore like what do those kinds of systems look like when they interact. And that feels vast. That feels really exciting and an opportunity to sort of re-envision from first principles what's possible. And maybe that looks like a kind of pattern where we're really describing interfaces of interaction between different modes. And that's what like polyculture and pluralism is fundamentally about. Is not just saying that the fast, dry MacBook Air logic is the thing that subsumes all other models of computation, but what does that interface look like and how does it work?
And so we're really interested in exploring this space of interface design. What is the form of expression that allows the wet, slow to communicate with the fast, dry systems that dominate our society today?
Mm-hmm. Okay, so we're going to talk about a few possible applications that we've been working on for this. This is part 3. Yeah, and I hope that this sets the stage, not because this is resolved, but sort of like minimum viable expressions of what this space of interaction might look like. What does it feel like? And we're going to go back to the buoy, the siren buoy, because everybody's asking us about these siren buoys. Everybody's so stoked. Just kidding. But like siren buoys, like maybe have this possibility to be a way of like opening up and inviting other questions. These systems live, interestingly, like I said, they don't have a kind of wall or like a reservoir which contains them. They are out in the big wild world. And so although there's boundaries that cut off the edges of this image, we understand that this system is sort of having its own pattern of entanglement. There's a set of conditions, but that different forces that operate under different rules are interacting together to produce different kinds of outputs, which are meaningful or meaning rich. And what's interesting about that is that these kinds of systems are autonomous. Like you don't need somebody to be tending to it. I mean, maybe it breaks periodically, but in actuality, like they have their own life and they continue. And so one thing we didn't introduce about this is that, but Will and I have both been working pretty actively in the space of like decentralized protocols and autonomous systems, and that's where some of these river computers out in the world get particularly interesting because they're doing their own kind of autonomous form of information processing and compute that's information rich, and it's a sort of historical legacy for the ways people have been interacting with computing systems. That begins to bridge on like, well, this is a sort of like its own entity. It has its own life. You don't have to reset it. It keeps going.
And I think, too, if the framing of computing doesn't fit for you, maybe another way to frame this is as a contract. What is the agreement between the swell and the buoy or the human listening for it?
Right. So the first project that we're going to show is called Wind Trust. That's really dark. I'll just flash this right here in case anyone wants to scan their QR code and you can look at it while we're talking. It's live. If you want to look at it in a more physical way, it's windtrust.io. Yeah, so this, oh yes, sorry.
Oh, we're blocking it. Yeah, so the Wind Trust was an experiment in self-expression of the wind. So it's a fund and a group that's controlled by the caprices of the wind. And we really wanted to experiment with the logic that's at play. So we all sort of understand and assume that it's natural, the dynamics of a market or the flows of capital. There's some underlying phenomenon going on there, but really it's somewhat arbitrary or constructed. And why is that any different than dictating the flow based on the movements of the wind?
Yeah, so part of the premise of Wind Trust is that we are literally creating a fund that is held in a digital address, and one of the members, which has primary authority on permitting others to govern the fund and also how the fund is allocated, is the wind itself, or an entity which has a direct oracle connection to the wind. So the wind/oracle is a member of our group, and it has the authority to like do the handshakes and sign the contracts with the authority to execute certain things, whether that be permission to access or the ability to like route resources in a certain direction. And it's not like we're saying this is a good idea. It's more like a minimum demonstration that it's possible to wire up like a capricious dynamical system to directly exert influence, not just into like whether or not a bell goes off or a siren is expressed, but actually controlling where money is moved, who's allowed permissions, and it's directly influencing control into socio-technical systems. That's like particularly well paired when you start talking about autonomous protocols and things like that.
Right, so you can think of this as a digital deer scarer or a digital buoy siren, right? And part of what's compelling here as well is what we want to do is make more legible, make more visible the more than human world. And you know, the wind is all around us. It's common, it has large effects on our daily life, and yet it's sort of hidden. And so this is a way to make that relationship more explicit or more concrete and tangible in a modern system.
Right, and to that end, okay, so if it could be any other system besides the wind, but when you arrive into the space, essentially the dynamical system has to be pointed in the right direction. we did a sort of silly governance project to decide what that direction would be, and it happens to be the geodesic curve to Göbekli Tepe in Turkey, which is like an ancient civilization. That's not particularly important, but we collectively determine where the zone of open is, and it's basically the game is like the wind's blowing the door open and closed. The wind is blowing things along routes, like value accumulates according to certain economic and like market logics. Like we understand the valorization of capital, and capital accumulation is very like a clear thing that people are interested in talking about and wanting to position themselves in the right channels of that kind of accumulation. But like tumbleweeds or snowdrifts, what happens when we allow sort of accumulation processes to be directly controlled and influenced by dynamical living systems, and it's sort of like, yeah, the wind blew the door open so you can go inside or not. And in so doing, we're basically trying to introduce a kind of like minimum viable version of like an oracle. And there's lots like an oracle system, which is essentially like a truthful input into a dynamic computational system or just any kind of contract computational system, period. And so there's a lot of work to be like, okay, like, how do you actually make this robust? What are the incentive models here? How will people gamify this? How will they not gamify it? But I feel like that's a design space, like things we could discuss and work on. And the point is that we're trying to create like particular moments where the wind is actually signing the contract in various forms.
I think it's interesting too in that it creates a connection, right? You have to think about what's going on with the wind and spend more time with it. I think right now there's a lot of separation, and so understanding this interface design and like how do we increase the surface area between the wet and the slow systems and the dry and the fast systems.
Right, and there's, I guess, a lot of projects that might say like, okay, well, we have a kind of representative, where we have an AI agent, or there's like talk around symbionts and stuff like that, and we have a lot of friends and people who really care about working in this space, and it makes a lot of sense. And I think this is a sort of provocation to talk about what is the direct ways in which the more than human world can exert influence on socio-technical systems without some level of trying to form it into some contrivance we are already familiar with. And maybe we're automatically doing that by making it legible, but it's an exercise in like multiplying the surface area by which the dynamical world is exerting influence onto the systems that we've created and engineered for ourselves. Okay, so then the second one is one we could talk about for quite some time. We'll only spend a little bit of time on it because it's very much a work in progress, and we want to we'll be spending a big chunk of 2026 directly collaborating. So Ngapui is the Maori word for an iwi in the Northland of New Zealand, and an iwi is like a tribal district, a tribal delineation. Noting iwis are kind of like reservations in the Native American context. They were created and inscribed by the New Zealand Crown or the Commonwealth when colonization happened. But in the lineage of different iwis in Aotearoa, there are such entities referred to as taonga, and taonga are sacred non-human entities. They can also be like dictionaries or like pedigrees or like family trees, sacred information, karakia, which are sort of like invocations and chants. But many taonga are like non-human entities. And this is happening in a sovereign region in Aotearoa, which means to say that in this Northland, ownership and political sovereignty was never ceded to the British Crown. So there's not many places in the world where that is the case. But this is a group that would say they do not live in New Zealand, they live in Aotearoa, and they've never ceded, they've never settled. And as part of the history, which I'll only speak briefly about, within the context of New Zealand, there was a treaty. Treaties are a very, obviously have a really marked and important history within the politics of indigenous sovereignty all over the world, but one in particular called Y262, which was a granting of the right for Maori people to be guardians of the more than human world, and in so doing, allowing non-human entities to have personhood. So if you're familiar with the rights of nature movement and the basis for like legal standing and personhood for non-humans, which effectively uses the court system according to its own logic to protect and allow life to maintain. Y262 is the sort of Maori native version of this. So we've been working for now maybe 2.5 years with several different iwis, but a kind of main trust that's a council of many different iwis that's interested in taking these ideas and embedding what would it look like to have these living contracts, what we call living covenants, occupy and be held by Taonga, by non-human entities, which extends the idea of Y262 so that it doesn't just have standing, but through these systems, they could have the ability to permission access to information, to hold funds, to be able to allocate resources in emergency conditions, which is the primary project in the Ngapui Living Covenant. So this is a case where a river Taonga owns lots of data about, not lots, but I would say maybe like 10 primary articles of data that are considered like sacred, tribal information. And also they've created a container where the data about the river's like state and its well-being is legally held by the river as this extension of Y262. So essentially, the river is a sovereign entity that holds its own IP and controls access to the fund and permissioning around the use of that fund during flooding events. So a flood risk mitigation strategy is being integrated into the sort of covenant that's held by the river itself, and we're developing like with them oracle systems, ways of dynamically controlling the state of a river in order to allow different like patterns and exertions within socio-technical systems to happen.
Right, and so we see this as, just to tie this back to earlier, the way the sort of like subtle dynamics of a river flowing are dictating the behavior of this digital system that supports access to the fund and controls permissioning.
Yeah, we're doing this with two other sovereign groups that we won't go into tonight, but there's an active area of interest in how this aligns. In some sense, I think it's sort of like self-abating anthropocentrism. You're using the terms and the means that of like how humans wield control over the living world against itself to sort of allow non-human entities to have not only the right to stand in court, but then the right to like fight back and have currency and be vessels of governance. And this is an idea that we've been referred to as living covenants and has gotten pretty popular as a sort of model of non-human rights and ownership that are dynamically controlled by a river's state. And a tribal council is responsible for setting up the covenant, but it's a continuation of a history of covenants. And maybe this is where the idea of like contracts becomes a more helpful term to think about. Contracts or agreements is a more helpful framing to think about these patterns rather than computation. I feel like we've kind of left computation behind at this point, and understanding like what are the sort of like, what kind of relationships have been held through contracts between humans and the more than human world. And we're really interested in this space and curious to talk about other applications that people might know about or are curious to explore that are culturally and contextually specific, because they have to be. But concisely, or they should have, like the kind of anatomy of a living covenant according to a really rudimentary technical stack is that there's some kind of set of thresholds or conditions around what would be determined like a state of emergency. The flood level is so significant that it will damage X number of homes or anyone's property at all. Those are determined through a governance council process in a way that's sort of like setting thresholds like the siphon and the intermittent spring at the very beginning. These agreements and these conditions run on digital public infrastructure, which I could say like doesn't turn off, but that's not necessarily true, but it's much more durable and resilient to censorship. It's effectively making it an autonomous system that is able to run and live in its own accord. Of course, there's like management and oversight and exception cases to exception cases that are all an interesting space of discussion or possible application. And then ultimately that results in this sort of like living covenant idea. So what started as sort of a premise to think through like, wow, there's probably like logic gates embedded into the stream while we're out on a hike, I think has helped us bend or flex the domain of what we consider computation to the point where maybe it's useful, maybe not so useful anymore. And we're talking more about agreements and contracts. And I'm of the opinion that sort of like operating agreements, legal code, economic code, and sort of like computational code are essentially all the same thing. They're legible to different systems, but it's all a kind of code. So in doing this work and understanding the cultural and contextual specificity of it, maybe agreements and contracts is a better way of describing it. So initially we had thought like, well, in understanding the meander of the Mississippi or the siphon effect of a river, we're like, there's probably contracts written in this water system that for those who are tuned to read it can understand, but that takes time. Or that's like a history of a kind of cultural practice, like in the Nile, the rhythm of its flooding and its ebb and flow, or how its course meanders, and there's sedimentary morphology and things that are shifting around. Those are kind of contracts that people have been engaging with in the logic or the computational logic of that river. And it's a part of a kind of like almost an archaeology or an anthropology, which feels like we like learned a lot from just saying like, okay, there's probably logic gates and there's an and or somewhere in this stream.
Right. So in a way, this is nothing new. It's maybe a rediscovery or a surfacing and making explicit of contracts that were already pre-existing and finding a way to encode that in digital systems.
Yeah, or rather than mining these systems for their mechanics to create a contrivance that we already know about, like how are there precedents for sort of different contractual or compute systems meeting each other at an interface. And so the invitation for you all is like, what does and doesn't stick out? What does seem to track? And more specifically, like where are there applications for this kind of thinking and this kind of possibility space in the worlds that you see? Like I would love to talk about that space because, again, harping on the kind of like the monocultural collapse of cognitive and biodiversity, maybe rediscovering what computation and like earth contracts looks like from first principles is the upshot. Like we can rediscover those things. And many people have never lost them, and that has to be, that knowledge has to be protected. Yeah. Okay, so that's pretty much it. We'll just like close off by saying this is the invite link to keep chatting with us about this sort of stuff. We'll share other projects and things that we've been working on. This is a Signal chat, but we'd love to like, rather than just sitting around a table with a pizza and hoodies or something like that, going outside and exercising one's own body somatically in the world and thinking through these things, I think is like how this new version of quote technology will emerge. So it's not just like a hiking club, like we just like to go outside. It's like maybe that's the better, I don't know, boardroom, or drag the boardroom into the stream or something like that. Yeah, and we'd love your ideas on potential applications, like what does that look like? And then, yeah, insights and advice about the space that we're working in, like what tracks. We've never given this presentation before. We were like not really sure like how to present it and what people were expecting. So yeah, refer a friend. We're just like incredibly grateful that you all gave 42.5 minutes of your time to hear us talk about this, and hopefully there's a sort of point, like there's some like first principles or some elemental quote truths that live in here that might have grown in you all, and like over time we can cultivate those together. Maybe not, no assumptions.
Yeah, and we'd love the meander together to continue, so please reach out either in the Signal chat or feel free to shoot us an email. Yeah, and again, thanks so much for showing up, and thank you to The Fold for hosting us. And we're gonna do a Q&A after this.
Yeah, we can do like, we'll stay here and talk and engage with any of the questions folks have or comments as they might be. And y'all are welcome to like hang out in the space. Maybe Jesse Kate will hang around and you can ask questions about The Fold. One interesting thread could be like, this is a space that's in formation and thinking about community assimilation and like what that looks like, community assemblages and things like that. So what might a system like that look like not just in an agreement, in a contract, but in a building case like The Fold. Right. We're not going to come too heavy-handed on that, but like that could be an interesting problem. So we'll stay here. You all are welcome to hang around. We'll maybe do Q&A for like 10, 15 minutes. Thank you.
Thanks.
Hi, yeah, in the back.
Hey.
Well, in this case, there's a representative body that is called a hapu, that is the voice, and the elected, like the elder council, that is the voice in speaking on behalf of the non-human entity. So the contract, like there is like an actual like agreement that is a contract that like we have signed in agreement with the iwi around discovering this, that maintains baselines of right relation and like what is an ethical collaboration look like in this context. So we ourselves are implicated in the contract, and a designated like governance council on behalf of the Engapui River, Mount Taranaki, 9 Mile Beach, or other examples of that. So there's like a kind of like representative entity and an iwi, and in this case, us as collaborators.
So just one more bite.
Yeah.
So when you talk of like the living covenant, what would be the entities that participate in that?
Just the ones that I described.
So is the river one, and then the representative indigenous people are another, or are they sort of?
The representative indigenous council in this case is the river.
Yeah, that's what I meant. So that's one party.
Mm-hmm. And then there's a representative council of, say, like people who are not elected to hold the role of council speaking on behalf of a river, who are still stakeholders, and people who are living in the region, which is to say they're not the council of representatives for the non-human entity, but they're citizens who are affected, they're human beings. So there's a designated like membrane around people who are entities who are specified to speak on behalf of the river in this context. But that doesn't include all indigenous people in this scenario. It's a specific group, as well as like representatives from the larger iwi, and in this case, ourselves. And going forward, there's like probably an agreement in some way with a funding entity that's like part of like a risk mitigation fund. That's 4. Mm-hmm.
Thanks.
Yeah, you were first, Jesse Kate.
Okay, you talked a bit about the sort of dangers of the copy-paste model of one form of computation onto the other. And then, like I'm torn emotionally because I love the examples that you're showing in the application, but on the other hand, it like raises the exact same question for me, which is, are we just copy-pasting the same models of computation and sort of projecting them onto, let's say, the tree or the river, and like coercing it into our modality of understanding, say, true and false or whatever.
Mm-hmm.
Sort of a secondary question is clarification. In the wind trust, you were pointing out that it's kind of it's like an art project, but you're not necessarily recommending it because perhaps like the direction of the wind or the amount of the wind doesn't necessarily correlate to like an expression of an opinion that would be rational in a decision-making context per se.
Mm-hmm.
And so, can you maybe talk about how the expression of, let's say, in the second example, like how does the expression map into something that we're supposed to like, treat as signal?
Mm-hmm.
Does that make sense?
Yeah. Wait, sorry. What was the first one again?
Yeah, just give us a quick teaser of the first one, because I went right to the second.
The first one was about this,
Oh, the copy pasting.
Right.
And the
Right.
second is just the type of logic and how it's actually instrumented to help make decisions.
I mean, I guess I would say that like I don't necessarily have an answer to how best design that, but I think that this as a framework or a design principle in interface design and system design is useful still. But like allowing the system to speak for itself rather than or just being aware of the biases embedded in a model that's acting as an agent or a representative for something else. I think that alone is a presencing, and then also that this is a space that we're exploring. I don't know.
Right. I mean, I think part of the provocation for tonight is to say, like, what are this phenomenon we see around making, like, the, quote, more than human world legible to different systems can be articulated across, like, in many different forms, and sort of the agent flavors, like, I am the river, I'm doing this, or there's a version that's like someone who's an advocate for it, like a council that's speaking on its behalf, or like a single, like a true, like a Boolean that's like, yes, flood state is triggered or no flood state is triggered, I don't think you get away from that. But more like, how can we have a kind of critical conversation around the ethics of like, what does that legibility look like? Who's designing it, and like, what are the assumptions that are embedded into it? For me, I would say like, I think there's a line of anything that like says like I am this, like a conventional computational medium that says I am another entity is like over a line for me. But it points at an intrinsic question around, if you make one system legible to it, you inevitably like invite it to capture in a way.
And is it corrupting, right?
Right.
Yeah.
So like legibility is like a dark forest. It's like by signaling that you're seeable, you invite the possibility of capture. And so I don't necessarily say like, this is right, that's wrong, but it seems like urgent that we have a rigorous dialogue around what the ethics and assumptions are around how we make these systems legible, AI agents, and the sort of like more conventional computation representational model being sort of one pole of this. For me, I find like state, like speaking in terms of conditions that are defined as like contracts being met or broken, seems like a more fruitful starting point than just diving into speaking like human English and trying to claim it has like mycelial consciousness and stuff. It's really hard to see into the audience.
Yeah,
I don't know who raised their hand.
And well,